Hello everyone, in this video we are going to discuss about combination of cells, that is battery. Actually last video we have discussed about the internal resistance of a cell, that is how the potential difference and EMF is varying with respect to the internal resistance of a particular cell. That is about only one cell, but here we are going to study the multiple cells which are connected in series and parallel combination. Why? Because this is very important. We can take our ordinary remote in which we are connecting two cells, right? Okay, actually here you know that this is connected in the form of what? Series. It appears to be parallel, but the original connection is in the form of what? Series. Okay, so whenever for example, this is a simple device so that two batteries are enough. Okay, whenever the particular applications is going to increase, that is power is going to increase, then according to that we have to increase the number of cells, right? That's what we are going to discuss about cells in series now. That is called a series grouping. That is, I have taken, you can able to see the diagram, I have taken the two cells of EMF E, okay, each, and the radius is nothing, internal resistance is nothing but R, small r. Okay, so now when the particular device is connected to a resistance called as external resistance R, the current will started flowing. The current entering is nothing but I, and the same current will be flowing through the device. Okay, and you remember, whenever I am going to connect the particular cells in series, the total EMF is nothing but NE. The total EMF is what? NE, and total internal resistance as they are connected in series, then I can able to write NR, that is R plus R plus R. I have considered it's nothing but internal resistance are same, that's what I have taken NR. Otherwise you have to take R1 plus R2 plus R3 if the internal resistance are different. Okay, now you can take the total internal resistance. Okay, the total circuit resistance is nothing but the internal resistance plus external resistance, because that is also connected in what? Series only, right? So internal resistance plus external resistance, then circuit current is equal to, hope you know that, so total EMF divided by total resistance, that's what we are writing. I is equal to total EMF NE divided by total resistance, nothing but R plus NR. Okay, now you can consider a special case here, that is if external resistance R is very greater than NR, then NR can be neglected. Can you able to understand? External resistance R is very greater than NR, then NR can be neglected. Okay, then I can able to consider only what? The particular external resistance alone. So NE divided by R. That's what I can able to write N into current due to one cell. Okay. N into current due to one cell. The next one, suppose internal resistance is very high and external resistance is very less, I can able to write, then R can be neglected, that is I is equal to NE divided by NR. So N and N will be cancelled, we will be getting what? E divided by small r. That is nothing but current due to one cell only. Actually here I can able to say that N into current due to one cell, so that whenever the number of cells increase, what will happen? The current also will increase. But here it is nothing but E by R only, that is current due to one single cell. So that when the number of particular cells are increased, the current is not going to increase. That's what I am going to call it as, in order to increase, get the maximum current in a series grouping of cell, the external resistance should be very high when comparing to the what? Internal resistance of a battery. So external resistance should be very high in the case of what? Series grouping. The next one is nothing but parallel grouping. Okay, you can able to see that in the parallel grouping, in the sense I have to connect many resistance one by one in the form of what? Parallel combination. That means both the positive, all the terminals should be connected at a particular point. Okay, all the positive terminals and all the negative terminals have been connected to a particular point. Okay, then that will be connected to a external resistance R. Okay, and you know that in the parallel combination, I already told you in the case of parallel and series grouping of resistor, that's nothing but when the cells are connected in, our resistors are connected in parallel, then what is the meaning? The total EMF is nothing but same, that's what E. I consider all the EMF are same, so total EMF of the battery is nothing but E. Then total internal resistance, that is total internal resistance is nothing but what? You know that it's a parallel connection, so 1 by Rp is equal to 1 by R plus 1 by R plus 1 by R, until what? M terms we have to take. So I can able to write it's nothing but M by R. Then I can able to write Rp is equal to what? R divided by M. Then what about the total circuit resistance? The total circuit resistance is nothing but R plus Rp. Then I can able to write R plus R divided by M. Okay. Now the circuit current, if you take, that is equal to, that is I is equal to E divided by again total resistance R plus R by M. If you take the cross multiplication and you can take it to the numerator, so our LCM, if you will get it as what? ME divided by MR plus R. Again I am going to consider the particular resistances, that is external resistance very less than small internal resistance, then MR can be neglected. So I can able to write MI is equal to M into E by R, right? MR can be neglected, so M into E by R, that's what current due to one cell. Similarly, when the internal resistance is very lesser than external resistance, then R may be neglected, right? Then I can able to write it as what? Small r neglected means you will be getting I is equal to ME divided by MR is equal to E divided by R. That is nothing but current due to one cell. Okay, you can take the consideration. Hence, in order to increase what, that is the maximum current in a parallel grouping, the internal resistance must be high and the external resistance must be what, very low when comparing to the internal resistance of each cell. Okay, so to get the higher power application, we are going with series combination. And to here, what is happening, the battery anyway, whatever the number of battery, what will have not change, the E value will not going to change. So that when I'm connecting many cells in parallel, it's not going to make any considerable change. That's what we are going with what, the particular total circuit resistance in the series combination to get the maximum value of current in the circuit. Okay, thank you, have a nice day.